Hey everybody, welcome to the Tone Priest Musical Contraptions and Electrical Engineering Super Deluxe Fandango. Today on the bench we have a super cool project. We have a JCM 900 made by Marshall. And if you missed the last episode about this amplifier, I'll give you a quick recap. Yep, so when the customer said when he turned the amplifier off of standby, it would blow a fuse. Definitely blew one of the high tension fuses, and possibly the mains fuse was blown as well. We're not sure. The details are sketchy. So we ordered up some parts, and we're going to install those parts and hopefully fix the problem. Alright, if that sounds like fun to you, stay tuned. Here we go. Okay, before we get started on this thing, I thought what we would do is just take a little gander at the schematic, try and familiarize ourselves with what they're doing here. And try and understand the circuit to the best of my ability, knowledge, and experience. So, with all that said, let's take a look. Alright, we start here. This is your input, so you plug your guitar in through a cable, you plug the cable in here. This is where your guitar signal begins in the amplifier. So we come in, go through here, and the first thing your signal sees is a dual op amp, this M5201. And the signal's going through both sections of the op amp, through the non-inverting sections here. And let's follow it here. Comes out pin 5. And this is our feedback loop. This sets the gain of the op amp. And also goes up here, does the same thing, comes out pin 5. So these two are actually the same pin. So it's drawn differently than what it actually is in real life. So this and this is just one point. Anyway, so we come in and we amplify the signal. In an all-tube amp, this would be where V1 is, and it would amplify the signal. It's doing the same thing, except they're using solid-state technology and not tube technology. Alright, so we come out of our dual op amp, and then it splits. So we got a little bit going this way, goes into this whole mess. And looks like we have a potentiometer here, B220K. It's probably a volume or a gain. I could be wrong on that. Continues on this way. Also goes up here. A1M, that's almost definitely a volume or a gain. Comes out of that pot, goes into the inverting op amp input. And it comes out here. So again, this is a second chip right here, M5201, another one of these. This is all one chip, and they're using both sections to amplify the signal. Comes out of pin 5. Now this section, I don't understand what they're doing here. The output's going to a bridge rectifier with the diode up here. I have no idea what that's all about. But it also goes down here into what looks like a tone stack, but one that's set. It's normally these would be potentiometers, so you'd have knobs to adjust the treble, bass, and mid. But they set it at the factory for you what they think you should have. If somebody were adventurous, they could replace these 3 resistors, actually 4. Could replace these with like 25K and maybe a 250K and a 10K pot. Drill holes in the chassis, and you could have another whole set of EQ. Alright, so that was from up here, and it went this way. Okay, so both of these go through there. So out of that tone stack, come out of here, another non-inverting amplification stage, goes up here, and some of that was from the first stage that was mixed in here. And now we're moving on here, and we go into our first vacuum tube. So this is a 12AX7, and 12AX7s are what are called dual triodes, so it's like two tubes in one. So we have two amplification sections. So signal's coming along, it's nice and amplified, goes through the 68K resistor, goes into the grid, gets amplified, and this has a 150K plate load resistor, so our high tension or high voltage is coming off of our power supply in through here. Gets dropped a little bit here. Most traditional amps, we could say, or vintage, use a 100K load resistor. This is 150K, so this is supplying a little bit more load onto the tube than what we could say is standard. But that's actually going to give this a little more grunt. This is going to change the operating point of the vacuum tube, but it's going to give it a little more grunt. But it has a very standard 1.5K cathode resistor, but there is no bypass cap here. A bypass capacitor would give the tube more gain, but I have a feeling this amplifier is not lacking for gain, so that's unnecessary. But you know, that could be a fun little thing to try out if somebody's adventurous. But anyway, okay, so we come in to the first triode of V1. We get amplified. Amplified signal comes out of the plate, comes up here into the grid. And now we have a cathode follower. So instead of using the tube like normal where the signal comes in on the grid, goes out the plate, the amplified signal goes out on the plate, the signal comes in on the grid and it's going down through the cathode. And with the cathode follower stage, that gives the signal, it's like more push behind it. And this is generally used for pushing a signal through a tone stack or a reverb tank or something like that. And that's exactly what they're doing here. So the amplified signal is going down through the tone stack. And if you look at this, it looks very much like this. Okay, the values are a little bit different, but sort of the setup of what they're doing here. But instead of having fixed resistors, we have potentiometers. So here's your treble, bass, and mid knobs right here. Alright, so we get pushed through the tone stack, come into a TLO72, which is like probably the most common dual op amp you're going to see in music electronics. Goes into the non-inverting amplification input here and gets pushed through the effects loop. So we come out of the effects loop down here, and this is probably the second half of this op amp right here. Goes into the inverting input and it gets pushed into, this will make up any loss through the effects loop. It gets pushed into V2, the first triode of V2. Comes out of the plate, the amplified signal goes through the plate, comes up here. And now the signal can go either this way or this way. Now, if it tries to go this way, it sees a 2.2 meg resistor, so that's a lot of resistance. So if it goes this way, it only has 470K of resistance. So a proportional amount, a greater proportional amount of signal is going to go through down here, but some of it will also go this way and end up over here. So you got your dry signal going through here, and it skips all this crap right here. And what all this crap is your reverb tank. So amplifies the signal, goes through these two sections of a dual op amp, which amplifies the signal some more, and that's pushing it through the reverb tank. Now, in process of doing that, the signal gets weak because it's got to go through springs and, you know, stuff like that. So we need to recover our signal from the back end of the reverb tank, so we can have another dual op amp, another M5201, which was the same as this guy right here. And that boosts our reverbed signal. Goes through a bunch of junk right here, and it meets with the dry signal right here. Alright, and that gets passed along into V2B, the second triode of your second 12AX7. Signal comes in, hits the grid, gets amplified, comes out of the plate. And it looks like we have master volume A right here. We have a 1 meg potentiometer, looks like 2 of them. We have master volume B. If this is a dual pot, then a master volume for both your channels, or if they're separate pots, then you know you have separate control of your master volumes. So this would be pre-phase inverter master volumes. We'll have to look at the amplifier itself to see what they're doing here. But anyway, signal gets boosted out of V2B, and it goes on to this schematic. So the signal comes out here, and it goes into our phase inverter, which is called a long tail pair phase inverter. Basically what this does is it splits our signal in two, and the first signal comes in from the grid here, gets inverted, and goes out to 2 of our power tubes. And then the signal also goes through this side of the tube, and the output of this side does not get inverted. And that goes to the other 2 power tubes. That way we can have push-pull. 2 tubes will be amplifying the upstroke, while 2 tubes will be amplifying the downstroke. That's what the phase inverter does, is it splits the signal into 2 equal but opposite waves. And then in push-pull configuration, like we have here, 2 tubes do the up, 2 tubes do the down. It's sort of like a bicycle. You have 2 pedals on a bicycle. When one of the pedals is up, you push down on that, the other pedal is down, and then they switch back and forth. Alright, so we have our 2 tubes, 2 sets of 2 tubes, power tubes, that go into the output transformer. And the output transformer transforms high voltage low current into low voltage high current, which goes into our speakers, and then we have rock and roll. Alright, I hope that made sense. Hope I didn't misspeak too much, and I hope that was helpful for some people to understand what's going on here. Alright, yeah, let's do some surgery. Here we go. Alright, we have the amplifier pulled out of the chassis again. And while we were waiting for the parts to get delivered, we did a little bit of house cleaning. We didn't clean the sockets yet, but we sprayed all the pots with, what's the crap there, the good stuff there. I got it over here. Deoxit. Alright, we deoxited all the pots, so that's good. And we inspected the circuit boards for any bad components or loose solder connections. Sorry, I'm a little out of breath here. This thing was about 800 pounds. But it all looks good. So we're just going to do a little bit of work, which we determined from the first video we should probably do. So that includes replacing these 2 filter caps. We have a couple of nice new F&Ts right here. So that's where we're going to begin. So let's begin.
Time for brass balls. The object is to catch this and make it across the bridge. Get it on!
Alright, so to get these out, these cans are multi-section caps are held in by clamps. So we need to unclamp them. And we will loosen this nut and screw. Spread those apart a little bit. There we go. Ooh, well, that's no good. Gonna have to go from this direction on this one. Hopefully the nut holds so we can loosen this. Is this? Oh my God, flatheads.
We come from France.
Yeah.
Oh, France. Well, that explains everything.
This is a bonehead that used flatheads on this. Oh, good. The nut isn't moving because it's right up against the other clamp. Alright, that should do it. Alright, we're going to flip her over and address the business end of these. Alright, here's the business end of these two caps. We need to finish desoldering these wires. And I've drawn a layout here. We could, of course, figure out what all the wires are for, where they go to, what they do, and use our brain to reassemble it. But why do that when we can just do this? This is easier. So yeah, let's do that. Alright, we have the first can out. And look at this. They friggin' clamped the shit out of it. That can't be good. Is that really necessary? Especially since they added some goop to it to keep it stuck in there. Whatever. Marshall. Alright, we have the two multi-section filter capacitors installed and wired up. Show you what else I did. We have replaced this capacitor here. I ordered the wrong capacitor, so I had to use one that was in stock, so we used an axial. But this will be fine. It looks pretty nice in there, nice and installed. That'll work just fine. And we replaced these two guys here with a couple of Nichicons. And the 2.5 millimeter spacing worked perfectly. So now we're going to move on to the grid stopper resistors on the power tubes. Hang tight for that. Alright, while working in here, I think we've discovered and deciphered a little bit more of how this circuit works. We have these 4 LEDs here. So that made me go, So they're labeled LED 1 through 4. Now if we look on the schematic, let me put you on screen mode here. Okay, so we find the LEDs on the schematic, LED 1 through 4. So what's happening here is, remember the guitar signal goes into the amplifier, goes through these two halves of the first op amp, and then they come out amplified, the signal's amplified. Some of the signal can come up here, and some of the signal can go this way as well, and that is going here into our 4 LEDs. We have 2 in series in polarized in one direction, and then in parallel we have 2 in series polarized in the opposite direction. This is on the output of an op amp. So what we have here is a classic hard clipping diode setup. If we had this set up in the feedback loop, like right here, that would be a classic soft clipping diode setup. So we basically have a distortion pedal built into the amplifier right here, right after the first gain stage. And I imagine that's what this pot's doing right here. This is going to be one of the gain pots for your distortion or your high gain, however you want to think of it. Cool stuff, right? Alright, so now we need to fix the error from the factory with the grid stopper resistors going to the power tubes. Okay, so this top half and this bottom half are basically identical. So we'll work with this bottom half. So out of the phase inverter the signal comes, and it comes here, and it hits this 1.5K resistor. It gets to this node, and it goes to the grid of this tube, and then it also comes down here, hits another 1.5K resistor, and goes into the grid of this tube. Now that is not correct. What should have happened is this node should be over here. So there should be a node right here, and you got a 1.5 into that grid, and then 1.5 into this grid. These guys should be in parallel, not series. There is no reason to do things like this. You will never get your tubes to match. It's just, you never get the bias to match. It'll screw up your signal. There's no reason to do this. This was probably a brain fart from the engineer at the Marshall factory. You know, probably some college graduate that, you know, has no experience making amplifiers and just had a brain fart and didn't see that obvious error. So we're going to fix this. We're going to take this node, put it over here. Let me show you in the real amp. Let me take you off screen mode here. Okay, R24 and R25 are two of the four 1.5K resistors that are grid stoppers. And that's for the two inner power tubes. So that'll be this one and this one. And then if we look on the outer two tubes very carefully, we gotta move some crap out of the way here. We see it's mounted directly to the tube socket. That's the way it should be on all the tubes, not just the two outer tubes. So what we're going to do is we're going to put jumpers in here, and one side uses an orange wire, the other side, the other two tubes, use this green wire, and we're going to do exactly what they did on this guy here. Have the grid signal wire, the orange one for these two tubes, go to pin 6, and then the 1.5K resistor will be jumped over to pin 5. Pin 6 is not used on a 5881 tube, so this is doing nothing, so it's just a convenient place to you know, make this connection. And then from here, we'll jump a wire from this pin 6 to this pin 6, and then we'll have another 1.5K resistor there, and so on and so forth. Does that all make sense? I hope so. And we want to thank Guitar CPR for pointing that out. Good stuff. Thank you, Guitar PCR, CPR, RPC, NPC. All right, we're on the underside of the board, and we have our two grid wires, or the wires that send the signal to the grids. And then right above them are the two 1.5K resistors we need to remove. And this might be a little tricky. It looks like they bent the leads over, which is fine. So we might have to clip the leads on the other side and then heat up the solder and pull out the remaining piece of the lead with a pair of tweezers. And this is all has added fun because I believe this is all unleaded solder, which doesn't stick as well as the leaded stuff, and it melts at a higher temperature. So I don't have a ton of experience with this, but you know, solder is solder. We're good at soldering around here. So anyway, yeah, so we gotta put jumpers in there, take those out, put jumpers in there. All right, we got those two resistors removed from the board. Once the leads were removed, we cleaned it up with a little bit of the wick. Here's the wick we're using today. Uh-oh. Uh-oh. Stuff here. What's going on back there? This stuff right here, the Chemtronics, no clean SD, it comes pre-fluxed, pretty easy to use, works good. So now, just going to clean up this area a little bit with a Q-tip and some alcohol, and then we'll throw some jumpers in, and then we'll move on to the tube sockets. Fun stuff. Alright, so this is why amplifier repair gets so expensive. Now, I could probably, you know, fix the grid stopper resistors without removing this board, but the potential for making, you know, like burning something with the soldering iron, and just the difficulty of moving around in those confined spaces, you know, it's probably just a much better idea to remove this board. And to remove this board, we need to remove all these knobs, and we need to remove all the potentiometer nuts, and we got to very carefully and gently lift this board up and out without wrecking anything, you know, and that takes time. It'll probably take a good half an hour to lift this board up, to get better access to the tube sockets here. So that's why, you know, good amp tech makes what, $60, $120 an hour, and it takes, you know, 2 hours to replace 4 resistors. Alright, a little more commentary about amplifier construction. So these potentiometers aren't secured with nuts on the face here. So we just removed all the knobs, and these will slide out. So this board, I believe, is just basically held together with, you know, this nut here and this nut here. But if we look in here, we see all of the potentiometers are soldered directly into holes into this PCB. So let's say, you know, this knob is scratchy and bad and you need to replace it.
In today's lesson, we will learn all about foreshadowing.
Well, you need to do what I'm doing now, which is remove this entire board to make 3 solder connections. Fun stuff. Alright, we got this board disconnected here. There's 3 sheet metal screws on the back here. Teeny tiny ones, 5.5 millimeter. Make sure you have one of those sockets handy. And there was a wire tie for the leads going to the reverb tank that we had to clip as well, so we could do this. But right at it. It wasn't that bad. Took about 10 minutes to do. So I guess the moral of the story is don't complain, just do it. Be like Mike. Oh yeah, that was the right call. Plenty of room to work now. Alright, let's stop talking about it and let's do it. Okay, now that we can see what's going on here, I'll show you what we need to do here. So, this orange wire here with the goop on it, and this green wire here are the 2 grid wires that our guitar signal comes in. They're in reverse polarity after the phase inverter. And this is coming through here. This is the jumpers that we just installed, so the signal left and right, or push and pull, however you want to think of it, goes to each one of these wires, and then these come out right here and right here. And then it's jumped to go over here to pin 6 through a 1.5K to pin 5. So this is correct here, but we just need to take these 2 leads and put them over here to pin 6 on this tube, and then jump a 1.5K resistor to there to make it look like this. So this one can stay the way it is, but I'm going to go ahead and replace this resistor, so we'll have 4 new 1.5K grid stopper resistors on all the tubes. So we're going to desolder basically everything, and then install the resistors and move that to there and that to there. Make sense? Alright, let's do it. Alright, got the grid stopper resistors all hooked up. Looking pretty nice. So this green wire here, the signal goes in, goes through the green wire, comes out here, goes to this pin, goes to the grid. And then we got another green wire here connected here, goes to this pin, goes to the resistor to the grid. Same over here with the orange wire. So there we go. Alright, let's clean this thing up. We got to clean up any solder splash, put it all back together, and then we can insert electrons. Alright, I was dialing the amplifier up slowly on the variac and testing voltages almost everywhere, and everything seemed good. And I got it to about 80 volts from the wall, and we should have started to hear some sound through a guitar, and I wasn't. And then one thing I didn't check was this node right here, which is to the preamp tubes. I wasn't getting any voltage here. And long story short, it looks like when I was desoldering the old capacitor here, I desoldered one of the legs of this resistor right there, and that is the dropping resistor coming off of the power supply connected to this filter cap That powers the plates on our preamp tubes. So that's what I was showing you in the B-roll there. So now, I think we're ready to make some noise. All right, let's find out. But other than that, she sounds, she seems great. Check this out. I'm about to dial up the amp, and I just checked to make sure I have my little portable size can of fire extinguisher here. And it's sitting right next to the CRC QD electronics cleaner. You know, if there's a fire and you're panicking, one might accidentally grab the wrong can because they look so much alike. How awesome would that be? Alright, let's see how we did with that little fix. Bam! 220 volts, perfect. 226 there. 228 there. Looking better. Alright, we should have some noise. Let's find out. There we go, that fixed the problem. Looking good. Alright, we got her on the current limiter, and she's glowing a little bit, so we know we're drawing more than a half an amp. And if we look over here on Mr. Variac meter, we got her dialed up to 101 volts from the wall, 650 milliamps total consumption, 60 watts. So we can't bias her up like this, so we're going to have to take her off the current limiter and hope and pray that my work is good. I think it is. I didn't really do anything too fancy in here. So we'll bias her up and take her off the bench speaker, and we'll find something a little more appropriate. I don't really have anything that can handle 100 watts, but maybe 50. We'll see what we can do. Alright, I think there's going to be a part 3 to this project. So, I have it up to 100 volts coming from the wall, and I was playing it, and it was crystal clean in the A channel, the clean channel. And I just touched the gain knob, and it's... I'll try cleaning that pot again, but, you know, I already douched these out pretty good with the deoxit, so... The owner did mention something about this had been sitting in a basement for a while, so those are probably all full of crud and yuck. Let's see how the other channel's doing here. Seems like it's just that one pot, so that's good, I guess. I might actually have, yeah, I probably have a pot that I can replace. So maybe there won't be a part 3. It'll be a part 2B.
Or not to be.
But anyway, where are we at here? Volume. Be quiet. Let's go back to channel A. Volume. Yeah, that pot is whack. Alright, let's throw a pot in there. Come back to this, and we'll bias her up. Alright, so we're looking for a linear 220K potentiometer with the PCB pin style. And the only thing I have here are 250K and audio. We can focus. Audio 250K, which probably isn't a big deal, but it's only this kind. I can make that work, and I'm going to do that now, just so I can continue with the troubleshooting process and make sure there are no other problems with the amp, because if we do have to place an order, we can get everything all at once. So let me throw this guy in there, and then we'll continue checking her out. Alright, we got the new pot wired in there. It's picking up phone interference. Here she is, and that's the channel A gain. And that's semi-permanent. May or may not replace that with a proper PCB mount type of potentiometer. But alright, let's see how we did. Okay, so channel A preamp gain, that's at 8. Master volume. Guitar volume. Oh, that's much better. Yep. Seems like that's the only pot that needed to be replaced. And these pots don't have a good feel at all. They turn real easily. There's like just not a good feel to them. It'd be nice to get all new pots, but a lot of things would be nice. All right, lead gain. We'll put that at noon. See what we got. Alright, she seems to be working. We're at like 107 volts. Let's bias her up. Dial her up and bias her up. Okay, this guy right here is our bias trim pot. And we're injecting 117 volts from the wall. And I have it adjusted for pretty much minus 50 volts. And the schematic says at that point we should have minus 50 volts. Alright, let's break out our bias probes, flip this sucker over, and see what kind of plate dissipation we're getting. Alright, while we are waiting for the tubes to cool down so we can remove 2 of them and put in our probes, the power tubes are TAD or Tube Amp Doctor 6L6 JCM STRs, red base. Spent a few bucks and got some good ones there. And then for my personal stash, V1, can't really see that. Yeah, still screaming hot. It's a modern Mullard tube, brand new. The second one is a National, made in USA. And that kind of looks like might be RCA made. And the final tube, the phase inverter, is a GE, Joint Army-Navy tube. Good stuff there. So yeah, so far she sounds pretty good. Can't wait to really try her out. Alright, let's probe her.
That's what she said.
Does this look sketchy to you? Yeah, this is fine. Alright, so we're not on the current limiter. We're going straight off the variac, feeding it 117 volts. We're drawing 116 watts, 1.18 amps. The plate of this top tube here is getting 459 volts, thereabouts. She's still warming up. And, which one are we on? We're on this guy here. So this is the red multimeter. We're getting 35.5 milliamps. So, give it a few more seconds to warm up. Yep, just pulling some juice. Alright, let's see where we're at here. Let's do some math and figure this out. Hang tight. Okay, so 457.7 volts on the plate times 0.0358 amps equals 16.4 watts of plate dissipation. If we check our data sheet here, What's the one we want here? Where are you? All right, here, plate dissipation. Trying to look through the screen here. Plate dissipation. 30 watts max for cathode bias. 70% of 30 watts, which we want to probably be closer to 60%. So we'll do 60% of 30 watts. So we're at 16.38. 30 watts times 0.6 equals, we're going to be around 18. So we're a little bit cold biased. But I think once she warms up a little more, that might change a little bit. So we'll keep an eye on her and we'll check again. But yeah, we're in a good spot right here. There's nothing to complain about that. About 58%, something like that. Let's check how the other tube's doing. Alright, I checked the other side, and they're both spot on. They're super matched. And we're at pretty much exactly 55%. And I know the rule of thumb is kind of 70% is the target. But I've seen a lot of texts and a lot of videos where actually we want to be a little bit lower than that, especially on something like this, because once this sucker gets going, you know, she dissipates some heat. And so I think 55 is a good place to be living right now. You know, and then the other thing is we have the negative bias set at negative 50 volts, and that's where Marshall is saying it should be. So, you know, I think we're in a nice, good spot right here. Look at that. These suckers are matched perfectly. And certainly I don't want to say mod, but the fix we did with the grid stoppers on the power tubes certainly help with that. You wouldn't notice it well, actually you would notice it in this configuration, or maybe not, I don't know. But if we had the two tubes on one side on the meters here, we would notice a big imbalance. But I guess we'll never know because we fixed that problem. But nice. She's looking good. Alright, I guess there's only one thing left to do. Let's pack her all up and plug her into a real speaker and see how she sounds. Alright, we got her back in the cabinet, and we're going to plug her into this nice Rolla Celestion Limited G1250 8-ohm speaker. We definitely can't crank this up all the way, but we can certainly piss off the neighbors, so let's see how this goes. Sorry about the lighting here. We got issues. I got this thing all packaged up. Got a speaker plugged in, guitar plugged in, turned it on, and then nothing. What I did notice was the channel select switch was illuminated red regardless of how it was pushed. And I'm doing a little troubleshooting here. I have it plugged into the effects loop. And that works. So we know it's something up in the preamp that's screwing up. But check this out. Take the guitar cable, stick it into the input. Bam. I think we have a faulty input jack here. Sorry about the lighting. Ugh. Let's see, do that. That's not helping. Son of a bitch. Ugh, I gotta take it all apart again. And we'll probably have to order parts. I don't know if we'll be able to get a switchcraft in here, or that's mounted on a PC board. Oh, this is gonna be a shit show. Can't believe this. Maybe if we're lucky it's just because it's dirty, but I don't have a good feeling about this. Alright, so I'm real tempted to edit this out of the video, the final video, but this is just too hilarious to not share it with the world. Remember how I was complaining about the light and the amp not working? Of course, I took the time to tear it all apart again, and then I realized I was plugging the fucking guitar into the foot switch jack.
You serious?
Ugh, I really am an asshole. Alright, I had to break out the big guns for this bad boy right here. Ugh, let's see what we got. Hell yeah. Check it out, she does bass too. It's pretty cool. Not anymore. Well, there you have it. There she is, all fixed up. Sounding really nice. Sounds like a Marshall. Probably because it is a Marshall. Don't get much better than that. Alright, I want to thank everybody for watching. I want to thank the Guitarologist Locals community for their help and guidance, and the Guitar CPR YouTube channel for their excellent videos on the JCM 900. They pretty much just told me what I needed to do, and I did it, and it worked. So yeah. Alright folks, got more cool stuff coming up real soon. I hope to see you then. Rock on.
Done!